In this video, we will explore arithmetic sequences, its definition, and examples. The definition of an arithmetic sequence is a sequence where the distance between each number is the same, and D equals the common difference. Let's go a little deeper into the definition or an explanation of arithmetic sequences. In this example, or in the sequence of numbers, I have -10, -6, -2, and 2. My question for you, is there a common difference between each term? So we want to look between -10, -6, then -6 and -2, then -2 and 2 to determine if I have a constant term or a constant difference between each of the terms in this sequence of numbers. If you answered yes, you're correct. Now, what is it? So really what we're trying to determine is what number can I add or subtract from one number to get to the next consecutive number in the sequence. So here I have -10, -10, and -6 are about 4 apart, right? If I add 4, -10 plus 4, 10 has a negative in front of it. Therefore, the larger absolute value is going to be negative, so I would subtract the numbers and keep the sign. 10 minus 4, of course, is 6, but it's going to be -6. So, again, here, I add 4. -6 plus 4 gives me -2. Add 4 again. -2 plus 4 is a +2. Therefore, my common difference here is actually D equals 4, and we know 4 to be positive. The general formula of an arithmetic sequence gives us the power to be able to find any term in a specific arithmetic sequence. So we're going to actually look at what the general formula is, and from that we're going to investigate each component. The equation or formula is a sub n equals a sub 1 plus d times the quantity of n minus 1. A sub n is the nth term in the sequence. A sub 1 is the first term in the sequence. As we just explored in our previous example, D equals the common distance or difference. And N equals the position of the term. Position of the term. Am I the first term in the sequence, second term, third term, fourth term, etc.? The idea of getting the general equation of a sequence is we take the general formula, the components of a specific sequence. From there, we're able to get an equation that is unique to that sequence, which will allow us to generate any term in that specific arithmetic sequence. So we're going to start by naming all the components that we need from the general equation to get a specific equation for the sequence. A sub 1 is -10. D, we already said to be 4. So I'm going to just substitute these pieces into the general formula. So we have a sub n equals -10 plus 4 times the quantity of n minus 1. I have -10 distributing the 4 gives me 4n minus 4, which is simply a sub n equals 4n minus 14. Now, what does this actually tell us? Let's check. So this is a sub 1, a sub 2, a sub 3, and a sub 4. Using the general equation for this particular sequence, let's see if we can determine what a sub 3 is. So I want to know what a sub 3 is. If we are looking at a sub 3, remember again that n gives us our position. So our position is at 3. So I have a sub 3 equals 4 times n, which is 3, minus 14. 4 times 3, 12, minus 14. A sub 3 equals a -2, which holds true. So This is the general equation for this specific sequence.